Hello and welcome back. This video lesson will address one Common Core standard on solving exponential equations. We'll take a look at a couple of examples. We'll talk about the inverse operation for an exponential, and then we'll do a little bit of algebra to solve. Let's get started by familiarizing ourselves with the exponential function. Exponential functions arrive in one of two ways, as exponential decay or exponential growth. Reading the function just like you would a book from left to right, you can spot an exponential growth function because it increases as I move from left to right. It's growing, it's a growth. Exponential decay does the opposite. Reading from left to right, you see that the function gets smaller and smaller, or decays, as x increases. You can spot exponential decay and exponential growth by looking at an equation. Standard form for an exponential function is y equals a times b to the x power. When you see a variable as an exponent, you have an exponential equation or exponential function. When this b value is a number in between 0 and 1, for example 1/2, you will have an exponential decay function. When this b value is a number greater than 1, for example 2, you will have an exponential growth function. We are relatively familiar with exponential functions. What we're going to do in this lesson is solve exponential equations to answer questions. This will be something that's relatively new for most of us. In order to solve an equation, we have to use inverse operations. For example, when we have 2 multiplied by x, in order to undo multiplication, we use the inverse operation of division. Exponentials will work similarly. We have an exponent that is a variable. In order to solve for that, we need to use the inverse operation for an exponential. That inverse operation is known as a logarithm. You can see on the graph an exponential function a to the x, where a is greater than 1, meaning it's a growth, and the inverse of that, the y equals log base a of x. Based on our previous work, we know that these things are inverses of each other because they reflect over the line y equals x. Let's get to work and apply some of these concepts. For our example, we're going to be dealing with the equation y equals 2 to the power of x, where y represents the population of rabbits and x is the number of days. The question we want to address first is, after how many days will the population of rabbits be 256? That will be our y value that we'll substitute into our exponential equation, and we will solve for x, which is the number of days. Looking at the graph of our exponential equation 2 to the power of x, we can see that it is exponential growth, and we want to find out when it's equal to 256. To get an idea of where that is, I can put 256 in y2 and graph. The time, or the x value at which that occurs, looks to be somewhere around 8. We'll go ahead and solve this using some algebra and inverse operations. The equation we're going to solve for x is 256 equals 2 to the power of x. Notice we're solving for an exponent in this case. Normally in the past you have used inverse operations to solve. If it was multiplication, you divided. If it was addition, you subtracted, and so on. Here we need to get this variable out of the exponent in order to isolate it. In order to do so, we're going to use logarithms. Our first step is to take the log of both sides. So we'll have log of 256 equals log of 2 to the power of x. Now we're going to use a property of logarithms that comes in very handy. You can, when we have log of something with an exponent, bring the exponent out front. This is just simply a rule for logarithms. With that being said, now we have the equation shown here. Solving for x will be easy from here on out. We have x multiplied by log of 2. This is simply a numerical quantity. It's a number. So when I have x multiplied by some number, I can get x by itself or isolate it using the inverse operation, which would be division. So dividing both sides of the equation by log of 2, we have log of 256 divided by log of 2. We can type these values into our calculator and find the actual number of days when the population of rabbits would be 256. Typing log of 256, the log button is here just to the left of the 7 on your calculator. Log of 256 divided by log of 2. And I will hit enter, and you will see that x equals 8. This means that after 8 days, the population of rabbits will be 256. Let's take another look at an instance where exponential functions or equations are used. The next example will deal with compound interest. We'll take a look at a situation and then a specific formula that can be used to solve. Suppose that Jim has $500 to invest. The bank offers an interest rate of 2.1% compounding continuously. How long will it take the money to triple? This situation, we will need an equation to use in order to solve. The equation we use whenever we see compounded continuously tells us that we need to use our equation that is A equals PE to the RT. In the equation, the A stands for the amount of money in the account. P is the principal amount, or the amount you invest at the beginning. E is a number. R is the rate or interest rate as a decimal, not a percent. And T is time, the amount of time it takes. One thing to be very clear about is E is not a variable. E is a number. It is approximately 2.7. E is an irrational number. Similar to what pi is, a number that does not end. It's a decimal that repeats on and on forever and ever. Let's go ahead and fill in some of the things that we know in the equation. We know that we start with $500 to invest. That is our principal amount, so I will fill that in for the P. As we stated previously, E is a number, so I will just leave that thing alone. It's approximately 2.7. The R is the rate as a decimal, so we need to convert that to a decimal, which would be 0.021. And the time is the T value, and that is actually what we're looking for, how long. So I will leave that as a variable. The thing that we have it equal to, the A value, is the amount of money we would like in the end. In this case, we want the money to triple. I start with $500. If I triple that amount, it would be $1,500 or $1,500. Now we'll use this equation and solve for our variable in question, which is t. In order to solve for the t, we need to isolate the exponential portion of the equation. So I'm going to divide both sides by 500. Doing so gives me the equation you see in green. Now I have the exponential portion isolated, and I need to get the variable t out of the exponent. Similar to our last example, we will use a logarithm to do so. Since our base for the exponent is e, we have to use a natural log in order to get the t out of the exponent. After I take the natural log of both sides of the equation, we can now use our trick for logarithms, which is you can move exponents out to the front. Doing so, now we can divide both sides by 0.021 natural log of e. Since this is all multiplication, we'll do the inverse operation of division. After the division, you can see we have natural log of 3 divided by 0.021 natural log of e. Typing that into the calculator, you will see that our t value is 4.96. And that would be 4.96 years that it would take the money to triple.